Hey everyone, welcome to CIS 17A once again. Today we are going to be covering lesson number 14, Pointers Part 2. Alright, for today we're going to cover pages 509 through 521 in the textbook. So we're starting off here with the section titled Pointers as Function Parameters. Now, before I start getting into the book, I want to correct something that I said erroneously in my last video. And that was related to where the symbol is placed when using a reference and a pointer. So I had said that with a reference, so we'll make a reference right now to x, that when we use the ampersand on the left side of an assignment statement, then that means that the way that the symbol is being used is as, or not as, but it is telling the compiler that this is going to be a reference variable, and then we have to provide the name of the variable that's going to be referencing when we declare the instance of a reference variable. And then later we learned about the address operator, and we learned that the address operator is the exact same symbol, it's the ampersand. And I said that the way you can remember which is that the ampersand, when on the left side of the assignment statement, means this is a reference, and when it's on this side, it's going to be used with a pointer. So let's go ahead and make this a pointer instead of a reference. Okay, like that. All right, and I said that's how you can remember the difference between a reference versus the address operator, which returns the address of x and assigns it to this pointer xptr. So I said that if this is on the right side of the assignment statement, then it is the address operator. If it's over here on the left side, then it's being used as to indicate it's a reference. And that's true with everything I just said is true with respect to the address operator. Now, I said the same thing applies with the asterisk symbol, that the asterisk when on the left side is being used to say that this is going to be a pointer. But then I erroneously said that it could be when it's on the right side, that it is being used as the indirection operator. And that's not necessarily, well, it's not true. So let me show you guys what I mean by that. So the indirection operator is the way that we dereference or access whatever value this thing is pointing to. So that could be either on the left or the right side of an assignment statement. So for example, we could say, or a CN or a cout statement. So for example, we could say CN and then say the value that xptr is pointing to, and that's going to assign from the user a new value into the thing that xptr is pointing to, in this case the variable x up there. But we could just as easily use this on the left side as well. So I could say xptr xptr is equal to some number like 45. Okay, and that's perfectly fine as well, right? So, and I could also do something like say int y is equal to the value of xptr. Okay, so there you go. So the asterisk symbol that we use to indicate that something is a pointer, like up here, can appear either on the left or the right side of an assignment statement and be used as the indirection operator. So for example, like I mentioned here, this is just going to take a number from the user and assign it to xptr, where xptr is pointing. This is assigning 45 to whatever xptr is pointing to. This is assigning the value that is contained within xptr to a new variable called y. All right, so I just want to make sure that I clarified that before I get into anything else. All right, so hopefully that's not too confusing. I know pointers are always confusing the first time you learn how to use them, but it's just like everything in life, it's just practice. All right, so that all being said, let's go ahead and talk about the new topic for the day, which is, well, one of the new topics for the day, which is pointers as function parameters. Now, the main idea behind using pointers as function parameters is that it mimics the way that we use reference parameters in function calls. So we know that when we use a reference in a parameter list, that it alters the original argument variable inside the function versus using a call by value, which passes a copy up to the function and does not modify the original. All right. Now, there's really not much different when we pass pointers to functions. So here's a function called double value, and notice the only difference, or the only thing that's new here for you guys, is the use of the asterisk to indicate that the parameter is a pointer to an integer. That's what this is indicating. Down here, we see that it's using the indirection operator, and then it's going to use this symbol, which is going to, which is the same as saying the val is equal to val times 2. So in other words, it's going to double the value, just like the function says. Okay, and then notice we're going to have to use this indirection operator in order to use the value that it's being pointed to, not the address. So that's all this function does, is just double whatever this is pointing to in value. So if it passes 4, it's going to be 8. If you pass it 10, it's going to be 20 by the time that it's done. All right, so again, notice the return type is void, and we're not returning any value because this is working or behaving functionally just like a pass by reference variable like we've seen previously. Now the other thing that's different when you pass a pointer to a function is that you have to use the the address operator to pass in the address of the variable that you're trying to modify. So that's the other thing that's different when you pass a pointer to a function. All right, so here's a very simple simple program. We have two functions, one called getNumber, one called double value, and we have the variable being declared here in main that is going to be passed around to the different functions. So here, these are both expecting a pointer to an integer. So again, we have to use the address operator when we call it with number, so that we're passing the address of number to the function. And then let's take a look at getNumber. It's probably just going to do a cin statement. So it's going to ask the person for a number, and then here we're going to read that value in. Note that we have to use the indirection operator, because if we didn't put that there, it's like we're trying to say that we want the user to enter the address of the variable. So obviously, we would never expect a user to know the memory address of something inside the computer. So remember, we use that indirection operator to modify the value of whatever input is pointing to, right? Because input is a pointer to an integer. So next, we call that double function that we just saw a second ago. It's going to double whatever the number is, and then it's just going to print out the value of number is number. And notice we don't have to use any notation here because number is just a regular integer variable. And then if we look at a simple run of the program, enter a number, person put 10, it prints out 20. Right. So this is just breaking down everything that I just mentioned. And then here, the warning that they give you is what I just said a moment ago, is that you should never try to directly read in a value to a pointer, right? You always would use indirection when you're reading a value into a pointer. There's no way that you have a crystal ball that you can look into the computer and know what memory address it's referring to. All right, let's see. Okay, here's another example. This one is using an array to get some sales data. So the big thing that this program is trying to illustrate is the relationship between arrays and pointers. So as it mentioned up here, pointer variables can also be used to accept array addresses as arguments. So notice down here that we have the function getSales, and it is taking a pointer to a double as its first parameter. Down here we have an array, sales, and when we call getSales, we pass it the name of the array, because remember, the name of an array is equal to the starting address of the first thing in the array. So we're calling the function, we're passing it the array by using its name. I think we did this in the last lesson, but I can't remember. But here's the other thing that's interesting, is that we, within the function, now they're calling it R for array. That's a pointer to a double. We know we passed it the name of the array. And then down here, we're using a for loop. And we also have to pass in the size of the array, the number of things that are in the array. And then we can ask the person to enter each thing one at a time. And this is where things are interesting. Notice that we're using the same type of syntax as if we were working with a traditional array, but that this is just a pointer to a double. So it's important to know that you can do that because we're going to need to use that in the lab assignment that I'll explain at the end of the text. All right. So again, we are declaring a pointer to a double, but we're using the exact same square braces like we would as if it was passing in an array. All right. So interesting to note that you can do that. So the person's going to enter in the sales data one thing at a time based on the number of quarters. And then we're going to just use another function to print out the array. And notice, same thing. We in the parameter list for the prototype, we're just saying that it's a pointer to a double. And then that means we only have to pass in the name of the array. And then down here under print, oh, total sales? I thought it was going to print the array. Oh, okay, I guess we're doing some calculations. So sum is equal to 0, and then we're going to accumulate things. Okay, and they're also doing something kind of interesting here. Recall last time that you can use the plus plus or the minus minus operator on a pointer to increase or decrease the address by 1. So here, sum is equal to 0. Remember, plus equal is the same as saying sum is equal to sum plus, they're dereferencing the array. So this is also a little bit different. So they're dereferencing the current address and putting that number into, or adding that number into the current sum. So this is going to take all the different things in the array and add them all together. And then, yeah, okay. And then it's going to move one memory address further. All right, so hopefully that makes sense. And then we're actually going to return the sum here. All right. So there you can just see that the person enters in all the numbers, and then it sums all these numbers up and prints out what the sum of all those different numbers is. All right. Now, it's important to note that you don't have to do it this way. If this does not seem intuitive to you, you don't have to do it like that. You can just use the notation like here and do the exact same thing. So they could have just said sum is equal to 0, sum is equal to sum plus r bracket count, and then not even bothered with this. Right? I think the author just did it just to show you the use of that plus plus minus minus. So in my opinion, this is less readable, right? And then he actually gives you an example down here that's even worse. So down here, he mentions this. Oh, no, not that one. It's this one right here. So this is a totally valid line of code, and it does the exact same thing that was done up here. But I'm just going to tell you, don't do this kind of stuff. Don't jumble. You know, this is doing 3 operations in one line of code. And the temptation I've seen with lots of programmers over the years of teaching is they want to kind of show off how smart they are and say, look at this, you know, look at I did all this in one line of code. Yeah, that's great. However, when somebody in your group, when you actually get a job, gets passed on to your code and they have to decipher this to try to understand what you're doing, you're not going to make a lot of friends, and they're definitely not going to be thinking when they look at this, wow, how clever that person is. They're going to be thinking something quite different. All right, I'll leave that up to your imagination. But anyways, yeah, don't do this kind of stuff. It's not good. And like I said, I wouldn't even do this. Right? I would favor using good old array notation when you're using a pointer as an array. I mean, that's the point, right? You're using the pointer as an array. Okay, so that's that example. Okay, before I move on to pointers to constants, let's go ahead and play around with a couple examples of using pointers with functions. So let's go ahead and just first let's even just pass pointer. Note that just like with all prototypes, you don't have to provide a name in the prototype. Okay, here's my definition. Okay, here we obviously do need to give it a name. Okay, there's x. So let's go ahead and just do a simple function that modifies the value of it, and then we'll print out to verify that we actually modified the original value. So x starts off at 0. Let's call our function. Before we do that, let's define it. So what does this do? Let's just have it modify the value. So we'll just say the value of PTR is now equal to 45. Okay. And then now here, we'll call the function, pass it, and then remember, what do we pass it? So pretend like we're in the classroom right now. Do we pass it x, or do we pass it star x, or do we pass it ampersand x? What is it? Pick one right now. Answer, ampersand x. So hopefully you got that right. Why is it ampersand x? It's ampersand x because we need to get the address of x and pass that to the function. Now I'm going to go ahead and run it just so we can see this work. So this should change the x from 0 to 45. Okay, so you can see it modified the original value of x from 0 to 45. Okay, and then let's see. Let's go through all the reasons why it's not those other things. So why is it not this? Well, that's passing the value of x. So that's passing the value of 0 to this. So remember, the way to think of it is that whatever you have in the parameter list for the function, it's like that is the left side of a declaration. So it's like we have this on the left side of an assignment statement. And then whatever is in the argument list, that is like what would be here on the right. Oh, whoa, hey, buddy, come on. Don't be all crazy. Too much coffee. All right, paste. There we go. All right. So hopefully that makes sense. So whatever is in the argument list is what would be here on the right side of the assignment statement. So think of that when you're passing an argument to a function, is that whatever is here would be here, and whatever is here would be here. Okay. So we know that we wouldn't do this, right? We wouldn't be able to directly assign a memory address. The only way we can assign an address to something is using the address operator. We can't manually assign an address. Okay, why would we not do this? Well, that's trying to use the indirection operator on a non-pointer variable, right? Does it say that? Does it say? Yeah, operator. I don't know, you guys probably can't. Oh, it doesn't pop up. I'm looking over at my recording. If I hold it over here, there's a pop-up, but you guys can't see it. But anyways, it's saying that, yeah, you can't use the indirection operator on something that's not a pointer. All right, so hopefully that makes sense why it's not all those other things, and it should be this. All right. So let's see, what else can we do? We can also use the indirection operator in the function to initialize something. So we could also do something like this. Okay, so here we're going to let the user modify the value of PTR. Let's try that. Okay, so it's waiting for me to write in a value. Let's put in 123. We can see that it has been modified now based on what I did. So again, you can use pointers to mimic the way that we would use a call by reference. And there you go. All right, let's go back to, oh, let's do some examples using arrays. All right, so same thing. Notice that I don't need to change. If I want this to be an array, so let's go ahead and say this is an array. Let's just put 1, 2, and 3. Okay. And then let's go ahead and try some other stuff. Let's start off, before we do this, let's start off with going back to here. Okay, now, this is where a little confusion can set in. You're like, wait a second, Mr. Fast. You just went through this big spiel about why we use the and symbol here to pass in the address. So why is this giving me an error message? Well, let's go back to the idea of left side, right side. And if you can answer to yourself right now why this is wrong, that's very good. All right, so remember, this is what would be on the left side of the assignment statement. This is what would be on the right side of the assignment statement. Okay, now the deal is that x is no longer a single variable. It's an array. It's a list of 3 different elements, each containing an integer. And remember that the name of an array is equal to the address of the first thing in the array. So this doesn't make sense to do this because x already is a memory address. So remember, the name of the array is equal to the memory address of the first thing. So that's what we're doing is we're passing the address of the first thing in the array to the function. All right. So hopefully that makes sense why we are not using the n symbol there, because it's an array, not just a single variable. All right. And then down here, we can do something like have a for loop. We would need to pass in the size 2, but I'll just cheat and use the number 3. Is less than 3. Normally we'd want to pass in the second parameter that's the size of the array, right? And then I plus plus. And I equal to 0. Okay. And not a comma, semicolon. There we go. All right. And then I can just go ahead and probably put some nice fancy CIN statement or cout statement that's something like enter value I or something like that. But then now we can just go PTR, and then we can use that fancy array notation, even though it's a pointer, and read in one thing at a time. All right, so that's going to read in 3 things into my array. Now, let's go ahead and do another for loop. And then we're going to print out each thing one at a time. All right, so all this is going to do is call the function. It's going to pass it the array, and we're going to see it override, and then I'm going to override these values down here, and then it's going to print out the contents of the original array. So let's try that. Ooh, we're already 20 minutes in here. All right. It's all right. You guys like watching this stuff, huh? You'd rather be doing this than watching Tiger King or something like that. All right, so enter in the 3 values. So 21, 67, and 99. All right, so I'm overriding the values of 1, 2, 3 with 21, 67, 99, and then it should print out those values here in the for loop. So now instead of 1, 2, 3, it's the numbers that I entered in the function. Okay. All right. So hopefully you guys can wrap your heads around that. That's passing an array or a regular variable to a function as a pointer. All right. It works. Oh, am I getting lost? Yes, I'm getting lost. All right. Pointers to constants is the next topic. All right. Pointers to constants. Now, we saw earlier that when we were using vectors, that when you passed a vector to a function, that it passed it as a pass by value. It created a copy of the entire vector into a new vector that was used within the function itself. And I said that you shouldn't do that. You should use a reference. And then it won't create a copy. It just passes the memory address of the vector to the function, saving you tons of time and memory. But then I said, well, what if the function is only going to do something like print out the vector? Then remember the trick for that was to use constants. So what we did is we just added the word const before the word vector, and that made it a constant vector, and then we had to use the reference symbol, the ampersand, instead. Now, there's something very similar when it comes to using arrays, or anything for that matter, with a function which does not modify or should not modify the contents of the thing that is being pointed to. So this is the same idea as when I told you guys to use a constant reference when you pass up a vector. So it's the same thing with pointers. If the function only is going to print out or display something and not modify it, you should add the keyword constant before the type of the pointer. So let's go ahead and look at an example of that. So here we have this for loop, which is printing things out. Let's go ahead and create a function that does that instead. So we're going to say void, and then we'll call it print. And it's going to get a constant reference. I'm not sorry, not a constant reference. It's going to get a constant pointer to an integer. All right, let's go ahead and copy that down there. Okay. All right, so let's go ahead and move this into our function. And then let's call this PTR. Call this PTR. All right. pass it x. All right, so now this is going to initialize the array one thing at a time and then call print and print out the array. So again, the only thing new is we're saying const. That's going to make it so that if I try to dereference PTR and modify it, so if I try to do something like this, PTR is equal to 45, I should get an error message because I told it that PTR is a constant. So you can see that red squiggly line. It's not letting me do that because I'm trying to modify it, but I said that PTR is a constant. All right. So let's go ahead and just run this. So we should see it just ask me for 3 values and then print those 3 values right back out. So 5, 2, 6. Let's say 5, 4, 2, 6, 4, 2, 6. So there you go. All right. So that's a constant pointer. I'm sorry, not a constant, not a constant pointer. It's a pointer to a constant. And the reason I'm correcting myself there is because a constant pointer is something different, which we'll see in just a second. So this is a pointer. This is a pointer to a constant. All right. Now note that the pointer can change. So if I wanted to, I could say PTR plus plus minus minus like you saw earlier, but I can't modify the value of the thing that is being pointed to. All right. So keep that in mind that I can change the value. I can change the memory address of the thing that's being pointed to, but I can't change the value of the thing that's being pointed to. All right. Let's go back here. So in this example, they're just passing the function pay rates as a constant to this because all it's going to do, as you can see, is use a for loop like you just saw me use to print out the values. And then down here, it's using that notation that we saw last time. So it's using the memory address plus some offset and then using the indirection operator to print out the value of that. So again, you don't have to do this if you don't want to. If you want to, you can just consistently use the array notation to do that instead. All right. Let's move on. Okay, next the book is going to talk about passing a non-constant argument into a pointer to a constant. And this is actually fairly straightforward. Now, what all they're trying to show you is that down here we have one array that is pointing to constant data. So in other words, the contents 1, 2, 3, 4, 5, 6 cannot be modified because they're constant. Down here, this one does allow you to modify the values that it contains. But notice that in the function, it is using a constant int. So the temptation may be to think, okay, I can only pass it this, but I can't pass it this because it's not constant, and that's not true. All that means is that when you call this function display value, is that the array numbers will be treated like it is a constant. So the way to think of that is, let's not be fancy, let's not use arrays. So let's go ahead and make another function. Okay, void, and say that it gets passed, I'll call it fun, and it gets passed a constant int. Okay, so nothing fancy going on there. And then down here, let's say that we say, call it x because we're original. And down here we'll say cout x. All right, so and then down here let's just call fun. We'll just make int z is equal to 3, and then we'll call fun 3. Z. Okay. So think about what's happening. Z is not constant. It's just a variable, an integer variable equal to 3. So really, what we're doing is we're just passing the value of 3 up to the function fun, and fun is going to treat x like it is a constant. So it won't. We can't modify x inside this function. So again, if this was like a print function, which basically it is, all it's doing is printing out x, it shouldn't have to modify x for any reason. So again, we can't say something like x is equal to 6. It won't let us because it's a constant. So that's all it's doing, is it's converting temporarily z into a constant. So that's all it's trying to say. And the same thing would be true if this was a pointer or an array. It's just saying that by adding the keyword const in the function, that you can pass it non-constant data and it will get converted temporarily to be a constant format for the duration of the function. Okay, so that's all that section in the book is trying to explain. All right, so okay, all right. Let's see. And then this is just saying what I've been saying over and over, is that if it's a print function or display function, then you should use const inside of it. Okay, so there are pointers to constants, and there are constant pointers. Now, let's just read these, and then hopefully it will make sense. So a pointer to a const, that's not this, that's what we've been doing. A pointer to a const points to constant data or constant item. The data that the pointer points to cannot change, but the pointer can change. All right? So that's what we've been doing. The thing being pointed at cannot be modified, but the pointer can point to different things. Now with a constant pointer, it's this. A constant pointer. With a constant pointer, it is the pointer itself that is constant. In other words, I cannot point at anything else. I can only point at one thing. Once the pointer is initialized with an address, it cannot point to anything else. Now what's not said here is that even though I can't point at anything else, I can modify the value of the thing that I am pointing to. All right, so hopefully the distinction between those two makes sense. So this is explaining a pointer to a constant. This is explaining what a constant pointer is. And I know that verbiage is very close and very similar. A pointer to a constant versus a constant pointer. It's just one of those little quirks of the language that you just need to memorize, and you'll eventually get comfortable in understanding the distinction. So how do we declare a constant pointer? We move the word const over from the left side to the right side after the star symbol. So this is a declaration of a constant pointer. Now, as it said here, once it is initialized, well, actually, it's not saying it here, so I'm sure it says it right around the corner. But when you declare a constant pointer, you have to provide it an initial memory address. So in other words, I couldn't just put a little asterisk here, and then, or I'm sorry, a little semicolon here, and then later initialize this with some value. And again, just don't think of it, there's nothing special about what's going on here. This is the same as when you declare a constant integer, right? So let me show you. Let's go ahead. I'm going to go ahead and erase all this and probably regret it because I'm going to probably have to rewrite all this later, but that's okay. Let's go back. All right, so again, forget about pointers for a second. If I wanted to declare a constant variable, I have to initialize it when I declare it to be a constant. I can't do this, right? Because if I do this later on, I just modified a constant. And as you can see, that's not allowed. So it's the same thing with a constant pointer. If the memory address that it's referring to can't change, I have to initialize it. So in other words, if I do this, if I make this now a constant pointer, star const x, I can't just do that. Because I can't say later on int y, and then x is equal to and y. Right? I can't do that because this is constant. So I can't initialize this eventually somewhere down the road. I have to initialize it here. I have to say y is equal to 0. Let's get rid of this bad code. Bad code is equal to and y. Right? So there you go. So that's a constant pointer. I have to initialize it with some memory address when I declare the instance of the constant pointer. And all I'm doing is moving the keyword const from over here to over here. All right, so like I said, you can modify the value of the thing that's being pointed to. So I can do this. I can say the value of x is now equal to 67. And I can print out y and see that the value of y has changed. So it started off 0, but it was now modified to the value of 67, right? So I can do that, right? I can change the value of the thing being pointed to, but I can't do this. I can't say int, let's use z is equal to 0, right? But I can't do this. I can't say print out that value there. And now let's monkey around with the pointer. Let's make it now equal to the address of z. And it says, nope, can't do that. Cannot change this. Whatever I am pointing to here, I will point to that forever. I can never be changed to point to something else. All right, so that's a constant pointer as opposed to a pointer to a constant. I know, it's a little confusing when you first learn about it. All right, now, it's worth noting, too, that these are not very common. That using this constant pointer, it's not very common. Using a pointer to a constant, very common. You see that all the time, but this is far less common. All right, so let's see. Okay, so next the book goes on to explain what I just showed you in that quick demonstration. So I'm going to skip past this and talk about the last form of a pointer, which is a constant pointer to a constant. So here we have the word const before the variable type and after the pointer symbol. Just like with constant pointers, you have to give it a memory address when you create it. So what is a constant pointer to a constant? It's just that. I cannot change what PTR points to, and I cannot change or dereference and modify the value of the thing that I'm pointing to. Now, these, if I said that the constant pointers are rare, these are even more rare. These are seldomly used. I think I've maybe seen it used one time ever in all my years. So again, a constant pointer to a constant is just you use const before the variable type and after the pointer symbol. Cannot change what is pointing to, cannot change the value of the thing I am pointing to. The only place where you would really ever use this is in something like a display function. And note that the way that it's being used here is he's offsetting it with count. So he's not modifying number. He's not making it point to a different thing. He's just adding that offset to it and then using that notation that we've seen before to print out the value of the thing that's being pointed to. All right, so that's a constant pointer to a constant. Again, very rare, not very well, not seen very often. All right, this is the last topic. The last topic is dynamic memory allocation. It's a very powerful feature of the C++ language. As it says here, it allows you to create and destroy variables, and this is the key, while the program is running. Right, so up to this point, we've always had to, if we had like constants or if we had arrays, we always had to tell the array ahead of time how big it was, or in the code we had to say how big the array was going to be, right? The only exception to that was with vectors. Vectors is the only example that we've seen so far where as the program was running, we were able to provide a number and then have the array initialized to whatever the user provided. That's the only place where we've ever seen it to do it, as they say here, on the fly. All right, so that's what dynamic memory allocation is. It means that while the program is running, while it is executing, that the user can specify information and that the memory can be allocated while the program is running rather than allocating all the memory at compile time. All right, so let's see how we can dynamically allocate memory. So we dynamically allocate memory with the keyword new, and it works just like it's shown here in this example. So we have a pointer to an integer, and notice that it's not being initialized with anything. So what we can do is we can use new to do it when the program runs. So this is going to make it so that IPTR is given a memory address, and that's just going to be done by the operating system is going to allocate that memory for the pointer. And then we can use the pointer like we would any other time, using the indirection operator to assign the value of 25 to, in this case, whatever IPTR is pointing to. And whatever IPTR is pointing to is determined by new. That's going to be the line of code that goes into the system and finds memory to assign to IPTR. All right, so let's go ahead and just play with that real quick. So let's go ahead and get rid of this. And instead we'll say that this is a pointer, not assigned to anything. And it's worth noting that when a pointer doesn't point to anything, it points to something called null, capital N-U-L-L. We'll see that in just a second. All right, so I can say PTR is equal to a new int. And then I can say cn to PTR some number. And then I can print out the value of, the value of PTR. All right, so that's dynamic memory allocation. Now, some of you, if you already know what this is right now, you're going, you didn't do something. I know I didn't do something, but we'll see the thing I didn't do in just a second. And if you do know the thing I didn't do that I should have done here, then give yourself a pat on the back. You know your pointers. All right, so here we got pointer. We dynamically allocated a new integer. It's waiting for me to read in a value. Let's put in 123, and then it should just print that value right back out, 123. So there you go. That's all there is to dynamic memory. Well, that's not all there is. We'll see with arrays that we can do more. All right, so that's allocating memory dynamically. Okay. Now you can also use the word new to dynamically allocate an array. And this is pretty sweet because earlier when we were learning about arrays, we saw we couldn't do that. We couldn't ask the user for a variable and then put the variable in here and then have it dynamically create an array of some size specified by the user. But with the word new, you can. All right, so let's see. So this is just going to dynamically allocate an array of 100 elements. And what are we doing here? We're just initializing the array to have all ones in it. Okay. Here they're just saying that the word new sometimes will fail. It'll fail if your program has run out of memory. And this only happens in large-scale applications. In small, in small projects for like homework assignments or labs, that's never going to happen to you. But it is worth noting that if you're, sometimes if you're working with something, I don't know, let's say you're making a video game, and you're going to have enemies that spawn, and it's going to create enemies throughout the course of the game. It's possible that you may allocate or try to allocate so many enemies in the game that the game runs out of memory. So what you should do, well, you guys don't need to do it because, like I said, it's never going to happen in something that you write for a school for a class. Is right after you call new, you should check to see if the pointer is pointing to null. If it's still pointing to null after you called new, that means that it failed to allocate the memory that you were requesting. So you should print out some error message and then, do some kind of house cleaning or tidying up or just handle the fact that it couldn't allocate it in some graceful way. All right. But again, you guys are never going to have to deal with that until you get a job and actually start making large stuff. Pointer contains the address 0. That's the null pointer, as I mentioned. 0 is an unusable address. You should never try to actually do anything with it. You shouldn't try to dereference it. All right, so here's where if you were already familiar with pointers, you might have said, hey, you didn't do this. So this is what I didn't do. Anytime you allocate memory dynamically, you should also delete it when that variable is no longer needed or used. And you should definitely delete it just before the program terminates. Anything dynamically allocated should be deleted before the program exits. So again, when something becomes outdated, when something's not used, or before the program terminates, you should delete it. Now, also, if you intend to reuse a pointer that has been dynamically allocated on another call to the word new, you should also delete it before you call new the second time. All right. So let's see. So this is how you would delete a single pointer. This is how you would delete an array. You just add the square braces between it and the name of the array and the word delete, open and close braces. All right. So to fix my program, all I need to do is this. Down here before I exit, I say delete PTR, and that's it. So that will give the memory that I allocated dynamically back to the system before I end it. Now, if I don't do this, if I just let the program run, that is what's referred to as a memory leak. So when you dynamically allocate memory but you never delete it, that's a memory leak. Memory leaks are very, very bad, especially on systems that run nonstop, like an ATM machine. Because what happens is, if, let's say, every time the user comes up to do a transaction on the ATM, let's say that it dynamically allocates, yeah, I don't know, 100 variables. Over time, it's constantly allocating memory, but it's never giving it back, and it's going to make the ATM run out of memory and crash. So memory leaks are really, really bad. So you always want to be responsible and delete anything that you dynamically allocate. All right, I am running out of, this is going long here. To be fair, though, this is a pretty complicated topic, so just buckle in, you guys. All right, let's see. So this is going to be this big long example here. Okay, I'm going to leave it to you guys to go through this example because I want to go through the lab before I run out of time. All right, let's see real quick how to allocate an array dynamically. So we can do something like this, and we can ask the user for a number. Let's declare another variable called size. And then let's go ahead and read in the size from the user. And then say, oops, size. Okay. So this is new. The book just put a literal in the example, but you can put a variable. So remember when we first learned about arrays, we couldn't do this. We get an error message if we tried to put that in. So down here, we're just going to say that PTR is equal to a new array of size specified by the user. Okay. All right. And so let's go ahead and then do something like this. To 0. I is less than, in this case, size. That's the number of times we're going to loop. I plus plus. And then we'll just go ahead and read in the values. So then we'll just see in PTR I. Okay. And then down here, let's go ahead and just do another for loop to print out so that we can see that it worked. Okay. And then because PTR is now an array, delete the array brackets. Okay, so this is a program that's going to allow me to dynamically decide how big the array is. And then I'm going to fill it up and I'm going to print it out. So this is very useful for the lab, by the way. This is going to be something that we need to do to solve the lab assignment. Okay, so it's waiting for me to say how big it is. Let's go ahead and make it have 5 things. Now I need to enter in the 5 things. Let's go 3, 4, 5, 6, 7. And then it prints out what I put in, 3, 4, 5, 6, 7. So that first for loop was doing the CNs. 3, 4, 5, 6, 7, 5 things. That's what I wanted. And then this for loop printed it out, and then I deleted the array. Okay, so that's dynamic memory allocation using an array. All right, and like I said, just leave it up to you to go through this example. All right, let's go through the lab so that we can get out of here because it's running pretty long. Okay, so for the lab, I'm going to skip past all this and just let's go ahead and just look at what the program is trying to do. So we're going to write a program that prints out a menu of 4 choices. The user can enter a name, they can print the last name that was entered, and they can search for a character in the current name. So the person put 1, they want to enter a new name. Next it asks how many letters are in the name. The person said there are 3 letters in the name. And then one at a time, it's going to ask for the letters. Now this should all sound very familiar because this is what I just showed you how to do in the example, right? So how many letters are in the name? Dynamically allocate the array, and then read the letters in one thing at a time, right? So A and A. And don't worry about error checking, okay? Don't worry about any of that. Just assume that the person's not going to do anything funny, okay? All right, next, it says, what do you want to do? Choice is 2, which is to print the last name entered, and the program prints out the name Anna, what the person put in here. That's, again, what you just saw me do here. So it's just going to be a function call in the lab. It uses a for loop to print out the person's name. Okay. Next, the person says that they want to enter a name again. Now, it's important to note that whenever the person puts in more than one name, you do not, for the lab, do not store the last name that was entered. So, like, don't use a vector or an array or something like that to store like a list of names. Once the person says they want to enter a new name, you wipe out the old name and replace it with the new name. Okay. So the person says there are 4 letters in this name, so one at a time. We get the person's name. They choose 2 to print it. It prints out the person's name. And down here, we have search for a character in the name. The person put 3. So it's going to ask the person, what character do you want to search for? The person wants to search for I. And then it's going to say, character I was found at position 2. So in this case, position 2 is letter 1, letter 2. So it found I at position 2. So that's what it's saying here. And then they say 4, and they exit the program. Okay, so that's what the program does. So let's look at some other cases. Let's say that the person didn't enter a name. So the person started the program, and the first choice they had is 2, print the last name entered. Well, there is no last name entered. So your program should then correctly report back, no name has been entered. So that is one form of error checking that you need to have in here. Down here, same thing. They put 3 to search for a character, but no name has been entered yet. All right. So remember, if the pointer is pointing to null, then that means that nothing's been entered yet. All right, and then they exit the program. Okay, so let's go ahead and look at some code here. So you're going to have, let's go and just start in main and then work our way through. Okay, so in main, you're going to have a pointer to a character, right, because they're entering letters, and initialize it to null, right? So that means nothing has been entered yet. You're going to have choice that corresponds to the menu choice that they selected, and then size will always be the size of the array, the number of letters in the name. Just like with previous assignments, when you use a menu system, you're going to use a do while loop that loops until the person chooses to exit. So that's, if the person is not chose 4, you can exit. And note that there's no error checking in here to make sure that they chose 1 through 4. You don't need to do that. All right, so what is the first thing you do? First thing you do is print out the menu. And then next, you're going to use this if-else-if structure, just like in previous assignments, to see what they chose. If they chose 1, that means that they want to enter a name. So you're going to ask the person for how many letters are in the name, and then check to see if the current name variable, this one here, check to see if it's equal to null. If it's null, then that means this is the first time that you've entered a name. If it's not equal to null, that means it's currently pointing to something else. And that determines whether we need to call delete or not. Because if it's pointing to null, we can just call new. So if it is pointing to null, it means it hasn't been used yet. We can just call the new operator to dynamically allocate the array based on the number that the person provided right here. All right. Okay. If the name is not null, then we need to delete the old array before we call new and allocate the new array. And then last but not least, we call a function called addName, which is not, this isn't a good name because you're not adding a name. That implies like that there's a vector and you're adding to it. This should just be called like update name would probably be a better name for this function. So then we're going to call the addName function. We're going to pass it the pointer to the, we're going to pass it the name pointer, and we're going to pass it the size so that it knows how many times to loop to ask the person for their letters in their name. So let's go up here and let's look at the prototype for addName. Oops. Okay, did I just, oh, I didn't use, interesting, I didn't use prototypes. I just declared everything up here. I was being a lazy teacher. You should use prototypes and then down underneath put the definitions. All right, so in the addName function, we're getting a pointer to a character, and then the size was the number of things in the array. So remember, A is going to be treated like it's an array, right? You're going to use a for loop to read in one character at a time based on the number provided by the user. Again, that's very similar to what you just saw me demonstrate using integers instead. Print name, check if it's equal to null. So you're going to have an if-else statement, and if it is equal to null, you're just going to print out there is currently no name to be printed or something like that. If it's not null, then you're going to use a for loop to one at a time print out each letter in the array that is there. Find character. Oh, and then notice, this one is actually going to modify the contents of the array, by reading in one letter at a time. So you're just going to make it a char pointer to a char. Print and find character should be constant because they're not modifying the contents of the array. They're just printing out the array, or they're just printing out that the letter that you're looking for is in the array. So print name function, check to see if it's null, and if it is, hey, there's no name to print. Otherwise, print things one at a time. Okay, find character. Check to see if it's null, same thing. If it's null, then you need to print out no name has been entered. Otherwise, if it's not null, ask the user for the letter that they want to look for. And then after you acquire the letter that the person is looking for, use a for loop to go through the array, one letter at a time, comparing the letter that was entered with the current value in the array. And each time you find it in the for loop, just print out, the letter was found at position, and then use the counter variable of the for loop to print out the number. And then again, I didn't use 0 through size -1. I just added 1 to it to make it say position 1, position 2, position 3. All right. And then if the letter was never found, you should also print out that letter was not contained within the current name. So you're going to have some additional logic in there that after that for loop executes, if it never hit on that letter, you have to use some type of variable, like maybe a Boolean, that once it does find a letter, you set that Boolean to like true. And then after the for loop is done, if that's equal to true, then you don't need to do anything. If it's not equal to true, then that means it never hit. It never found the letter, so you should print out a statement that says the letter was not found in the name. All right, so hopefully that all makes sense for the lab, you guys, and helps you out. So you can see down here, it's very simple, right? If the choice is 2, you're going to call the print name function. If the choice is 3, you're going to call the find char. Both of these, well, actually all of these functions, as you can see, you're doing the same thing. You're just passing it passing it the array as a pointer and the size. The only difference is that we're making it const here and here. All right, I'm sorry, that was a very long video. That's the longest video that I've recorded this semester. But to be fair, pointers are a fairly challenging topic the first time you learn them. So hopefully you guys are able to get through this okay. As usual, if you need help with anything, please do send me a message in the inbox and I'll try to help you out with your problem. All right, good luck on this, you guys, and I hope your semester is going well. We're getting close to the end. Hang in there.